Hi everyone, I will just briefly show you how this automation tool works. Basically, it can help match the harmful terms from your local XML files. And once you download and open the file from our GitHub repo, you can see the similar code. And before it starts, we need to... Hi everyone, I will just briefly show you how this automation tool works. Basically, it can help match the harmful terms from your local XML files. And once you download and open the file, our GitHub repo, you can see the similar code. And before it starts, we need to import all the necessary packages and do the settings. Do all necessary changes to the code based on your local files like the path, the name, etc. The first step, parsing XML file to data frame. This step is to parse your local XML file to data frame. And some files are with namespaces and some are not. You might need to tailor the respective functions depends on the actual situation. And this function, parse XML to DF, is designed to... This function forms the basis of the XML parsing process in this script. And once this function is defined, this is just another case for the XML files with namespaces. We need to define the namespace for it and do the same thing. And once the function is defined, we can use it to parse one single file and give the function your local file path, and it will give the results. You can see in this table, the parse data frame now has the source file name, the EAD, ID, abstract, etc. And this is just one example. And what if we want to parse multiple XML files together and want to parse them all together from a given local directory? We can do the similar thing. We can first define and use the parse XML folder to DF function here. And it takes as input a folder path and returns a single data frame containing the combined data from all the XML. We want to parse multiple XML.
So we're doing a little bit of figuring out how to get the sound to work. But this sound works. What? You can hear me. Well, we can start with the calisthenics. You all ready for the calisthenics? Right, that means, ooh, that's a little bit loud. That means that I'm going to ask questions and you're going to raise your hand and get all sorts of exercise, right? Okay, first question. How many of you are thinking, who the hell is he? Yeah. Well, you're half right. You got the hell part because my name is Hellman. And you got the pronoun right too, so good for you. Okay, what else? Next, we move to newcomers and veterans. So who in the room is at Code4Lib for the first time? I want you to stand up this time. Stand up. This is exercise, okay? All right, everyone else knows to applaud the newcomers. And what the veterans are thinking, these people are going to be feeling like veterans very soon. All right, now, if you have been to Code4Lib before, you can stand up now. All right, thank you very much. And the goal for the veterans in this conference is to feel like a newcomer, because you're going to meet new people and you're going to learn lots of new things. Okay. Undo, cancel. Oh, okay. So now we have some announcements, and I lost my place. On the screen, you should be able to see pictures of your community support volunteers for Tuesday morning No, that's today. It feels like a little bit later, doesn't it? So the community support volunteers for the morning are Sujong Herring and Bobby Fox until 11 o'clock. And then they will be so exhausted that Eric Pettiplace and Andromeda Yelton will take over from 11 to 1. So those people are supposed to be located in the back of the room. Please wave your hand if you are one of those people. Ooh, way back there in the corner, I see 1 and 2. And how about our afternoon, our later in the morning volunteers? There's Andromeda. There's Eric. Okay. Yes. They have zebra striped lanyards. Yes. Okay, the online community support volunteer is Coral Sheldon Hess. Coral on Slack from 8:30 to 11 a.m. Coral, please wave your hand, whatever. And then Natasha Allen on Slack from 11 to 1. So QA for Zoom and YouTube, all QA for Zoom and YouTube should be on Slack. So ask questions on Slack. Remember to check the pinned threads at the top of the Code4Lib Con channel. All right, I don't see the notice. If you put your name on for either a breakout or a lightning talk for tomorrow, Wednesday, those disappeared and you need to go and put your name on there again. We have obtained a few more power strips, so please be cooperative and open to power sharing. If your device is fully charged and can stand a few minutes unplugged, please allow for someone else who needs to plug in. Okay, this conference would not be possible without the work of the Local Planning Committee, also known as the LPC. Please take a minute with me to thank these people for their efforts. From University of Michigan, Natasha Allen. Jesse Johnston. Yay, Jesse. Ken Varnum. Ken somewhere. And Heidi Burkhardt. Heidi. There is a quiet room available down the hall in Kalamazoo. If you're looking to refill your water bottle, just outside the ballroom, make a right, it will be on the right wall. Bathrooms are also located down the hall past Kalamazoo. There is a single-stall, gender-neutral bathroom located on the 3rd floor. Reminder that power strips are set at tables in the perimeter of the room. Another power strip reminder. Please sit in one of the tables with a power strip if you need to charge your laptop. Okay, that's pretty obvious. All right, lightning talk updates. All slots are full for today. Yay, 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 let's hear it. Yay, lightning talks. Okay, here's the notice about the missing breakout sign for yesterday. So there are fresh sign-up sheets in the hall. And if you signed up yesterday, do it again. We promise we'll keep these. And breakout sessions. There was only one breakout session on the list yesterday, so there are still several slots available for breakouts this afternoon at 2:15. And now, it's time for talks. So our first talk is in person. It's Jess Johnston and Ella Lee, joining by pre-recorded video, which we hope we can play and we will be able to hear the sound. And the title is Encoding Reparative Description, Developing Tools to Analyze Problematic Finding Aids. Jesse? Here.
Thank you. And good morning, everyone. Welcome to day 2. We're super thrilled to see you all back and excited that day 1 went pretty well. Do I need to change something, or you're just waiting for the sound? Okay. I wanted to say, as we get started here, my name is Jesse Johnston, and my co-author and presenter is Ella Lee, who was not able to be here today, and she's working on some visa issues, but she has pre-recorded a video, so we have hopefully have that working well. And the second note I'll make here about my slides is that you'll see in the sort of lower left-hand corner that there's a short link, and that will take you directly to these slides on Google Slides. They're also in the OSF repository. But I won't read out the link every time that I change slides, but the link is bit.ly/3 CQ A So this morning, I'm really happy to be here to talk with you about a project that Ella and I worked on related to a reparative description project that's been ongoing at the University of Michigan. So I'm going to start this morning telling you a little bit about that project, which was called Reconnect, Recollect. I'm then going to talk about the data that we were working with, which was a set of finding aids that we received from repositories at the university. And then I'm going to talk about how we processed that data. It was a sort of coding approach, and yesterday there was some discussion of Python notebooks on the Slack, and we used Python notebooks, so you'll see a little demonstration of how we did that today. And then I'll wrap up talking about what we found, what we think the potential use cases of this may be, and a quick wrap up. So first, let me tell you a little bit about the Reconnect, Recollect project. You'll see this abbreviated on the slides as RC/RC. And this is an ongoing project that is working to assess Philippine collections at the University of Michigan. The project was led by Ricky Punzalan, who is actually here, and Deirdre Dela Cruz, who is in the Department of History and Anthropology. And they received internal funding from the university a few years ago, starting in 2020, from a project called the Humanities Collaboratory, to do a cross-university assessment of Philippine collections, figure out what we have here at the university related to the Philippines, and work on restoring or repairing relationships with some of the source communities for those collections. So they surveyed Philippine collections across the university, and this wasn't just library and archival collections, this was object collections, print materials, photographs, natural history specimens, which there are quite a lot here at the university. So this was the recollect part. And then they worked to establish the relationships and engagement with some of these source communities. So that was the reconnect part. So what I'm talking about today is just a small subset of that project where we worked to support reparative description aims of the project, which drew these two goals together. And we were working specifically in this case with finding aids. But before I move to the finding aids, I do want to give you a little bit of context. One of the first questions I got when I presented about this was, but why the University of Michigan and why the Philippines? And one of the reasons is that there are significant holdings of Philippine-related or Philippine-sourced materials at the University of Michigan because there's been a long history of faculty research involvement in the Philippines, which you might also say was extraction. And this is kind of what it looked like in the late 19th century on the left. This was the Steer expedition, which was led by a professor and some graduate students to go to the Philippines, which was not yet an American colony at that time, but they were sort of, doing an assessment to look around, see what sorts of flora and fauna were there and what sorts of resources might be of interest. They look kind of like settlers and Old West cowboys to me. They certainly were going on an expedition out into the wilderness. So this is just one example of a number of different faculty who were involved with research in the Philippines. All the way up through the 1950s and 60s and through until today. But they were actively collecting all the way up through the mid-20th century. So there are natural history specimens, archaeological specimens, etc. I would say, I made this slide to just kind of give you an idea of the contrast between how we're approaching this now. And on the left is a slide from 2022. In the center there is Deirdre Dela Cruz, one of the project co-directors, and some other students who were working on the project. And they're presenting at a local community event that raises awareness of the Philippine American community. And they were bringing examples of the collections to these communities. So the relationship with these collections has changed a lot over time. And the current approach is to focus on what they're calling reparative curation, which they describe as an ongoing approach to managing cultural and historical collections that seeks to address some of the historical injustices, colonial legacies, and systemic biases that are associated with these collections. They have a really wonderful website that is set up. The link is, I believe, in the notes to the slides, but it's reconnectrecollect.com or .org. .com, thank you. And there's a number of tools there that give an overview of the Philippine collections, glossary of harmful terms, which I'll talk about a little bit more soon, and links to some of the reparative description tools, as well as many other things. So the project portion that I'm going to speak about this morning is where we were working to identify and analyze what the nature of the current descriptions and metadata are about the archival materials. And so this quote is from the project website, and they stated that once the project developed an overall understanding of the scope of collections, we quickly realized that the large scale of work required to address problems in the multiple descriptive metadata systems would benefit from bulk editing and analysis. So we're talking about 250 or so archival collections that they identified. Some were described in the 1940s, 50s, and 60s, some much more recently. And we wanted to see how these were described. And whether they would benefit from some changes. So we thought that it was probably going to be important to do this with some sort of automated approach. So there's a number of discussions happening around about reparative description. You may hear it described as conscious editing, inclusive description. There are a number of approaches that are working on this. And I would say all of us that are working on it have decided a find and replace is not what we need, right? We don't need a kind of like tool that's just going to tell us where the words we don't like are, because that's far too simplistic for the kind of ultimate goals. So we were looking to answer the questions like, how might automation enhance reparative description? Like, how might these tools support it or make it more efficient? And we weren't really looking for the tools themselves to repair the descriptions, that is, to make changes, but to provide a diagnostic. We're also trying to move beyond term lists, which is kind of generally where this kind of project starts, because we get a list of terms that might be problematic, and then we find them and figure out what to do. So instead of just finding the terms, we were trying to figure out how we might better analyze them and come to some insights about them. And we're also interested in how prevalent the terms that were identified actually were, and if they were prevalent, where did they occur in the description? As you'll see, that actually is an important question about how you might address them. And we worked on some generating useful reports and visualizations that might be helpful to inform further action. And then finally, we're interested in a broad way about what these patterns of term usage might tell us. So I'm going to move into the section sort of overviewing the project now. A lot of this is going to be Ella's video, and I'll give a quick overview of the data that we were working with before we get there. So there are two main data inputs here. One is what I call the data set, and that is the set of the finding aids that we were working with. These were identified by the Reconnect project, students and faculty that were working with them. We used the finding aids more or less as we received them from the repositories, which is to say they were XML documents in encoded archival description, or EADs. And the data that we're working from in these visualizations comes from March 2023, and there have been some updates. So in fact, if you look at some of the descriptions, you'll notice some of these problems have been addressed. And then the second input was this modifiable list of terms that were identified. So this is something that we were hoping, if this tool is useful for others, might change based on user selections. And in our case, we were using those that were identified by the project. So the data set we were looking at had about 247 finding aids, and it came from 3 different repositories within the University of Michigan. So if you're familiar with the University of Michigan, you may have heard of the Bentley Historical Library. That's our main campus archives. That was the source of most of the finding aids, 157, and you'll see it listed on the slide here as Bentley. And then there's the Clements Library, which was about 30% of the finding aids. There were 67 from the Clements Library. You see that here is Clements. And then Special Collections Research Center, which is Special Collections here, had about 23 collections. And what we found was not all of these EAD were equal. In fact, there was considerable variation, which ended up meaning that Ella had to figure out 2 different routines to actually pull data from the finding aids. Generally, they were all valid EAD, but they used different schema definitions. So one used the XSD and one used the DTD. There were some invalid DTD declarations which referred to local documents that we had to sort of fix. And then somewhat oddly, because they were using the same systems to us, they all followed different file naming conventions. So we had to sort of reverse engineer a little bit kind of how we were going to work with that. And as anyone who has worked with EAD knows, this is probably a feature, or a bug. And it can be a little bit frustrating to deal with EAD, different versions, etc. So the second data input we were using is a list of terms. So this is user or project supplied terms. You can see a sample term list here that is just a sample. You'll see how it works within the code that Ella developed. And one thing about the terms is that these were identified by Reconnect staff and faculty and researchers, and some are very generic, right? They come from controlled vocabularies like the LCSH, which is the Library of Congress subject heading. So these might be things that are sort of more or less everyday words like dwelling, enemy, hygiene, primitive, uncivilized, but in the context of a colonial collection might have some problematic connotations. And then there are some that are relatively specific to the Philippine research. So things like insurgents, which would have been used instead of revolutionaries to describe indigenous Filipinos potentially in the late 19th century from the American perspective. Headhunters, which was commonly used to refer to certain upland tribes in the north of the Philippines. Benevolent assimilation, which is an American colonial term, ilustrado, which is a Spanish colonial term, and PI, with periods. So that's for Philippine Islands, which was a common abbreviation for the Philippines at the time. And two more things to note about how we process the data. We focused on the narrative sections of the finding aids. So if you're familiar with finding aids, that means we were looking at the biohist note, scope and content, and subject terms. We weren't looking at folder titles. And we made some decisions based on those terms that we were looking at about how we did term matching. And I think this goes back a little bit to what Libby was saying yesterday. We weren't actually interested in fuzzy matching or kind of potentially semantically related terms. We were interested in the very specific terms because these were coming from generally controlled vocabularies. And so we were sort of inspired by the concept of synonym rings in the sense that we were trying to group terms together, but we didn't want just sort of randomly or fuzzy match related terms. And as we noted when we were going through the data, the potentially related terms in terms of word similarity were not particularly significant. So I'll talk about an example of this with the singular and plural, or what we thought was singular and plural first later on. So cross your fingers. This is Ella's video, and she's going to demonstrate how she put together the code. So this is all running in Python notebooks, and she'll walk you through some of the functions that we used.
Hi everyone, I will just briefly show you how this automation tool works. Basically, it can help match the harmful terms from your local XML files. And once you download and open the file from our repo, you can see the similar code. And before it starts, we need to import all the necessary packages and do the settings. Do all necessary changes to the code based on your local files, like the path, the file name, etc. The first step, parsing XML file to data frame. This step is to parse your local XML file to pandas data frame. And some files are with namespaces and some are not. You might need to tailor the respective functions depends on the actual situation. And this function, parse XML to df, is designed to parse the file and convert its data into a pandas data frame for further analysis. This function forms the basis of the XML parsing process in this script. And once this function is defined, this is just another case for the XML files with namespaces. We need to define the namespace for it and do the same thing. And once the function is defined, we can use it to parse one single file and give the function your local file path, and it will be the results. You can see in this table, the parse data frame now has the source file name, the EAD ID, abstract, etc. And this is just one example. And what if we want to parse multiple XML files together and want to parse them all together from a given local directory? We can do the similar thing. We can first define and use the parse XML folder to df function here. And it takes as input a folder path and returns a single data frame containing the combined data from all the XML files in that folder. For example, this pass we put in here, and it will finally give us, this is a very long data frame. Let me. Okay. And data sometimes it make the table really large. And so yeah, that part we put in, it gives us 67 rows and 20 columns result. And you can also choose to download the table to CSV format, and you can check it through Excel or Google Sheet. Then the next step is about term matching. This part enables matching specific terms in your dataset. These terms are defined in a text file, and the structure of text file in our case should be that each term on a separate line. And you can define and create your own text file and for the terms you want to match. And next, where this match terms function searches for each term in the specific columns of a given row in your data frame. And if a term is found in a paragraph of a column, a dictionary with details about the match, including the term, the numbers of matches in that paragraph, and the paragraph text itself, and other related information, will be included in these dictionaries are appended to the results list. And after we match and realize, calculate the frequency, we can see and we can get this table. And we can see in this table, for each match term, we can now see where is it from, like the EAD ID and source file name, and which section it is matched from, which subsection, and how many times it is matched in that file, and the specific text paragraph around that term. This result can also be exported to CSV files. And these are also some big tables. And after that, the last part, we also did some realizations. You can also modify this to build your own realization or create your own realization using other method. We first created some bar plots for the term frequencies in each data frame. Here are the tables and the coding realizations. This represents the different sources of the data and their frequencies of the match terms. And next part, we did realizations for identifying the elements with highest occurrences of the specific terms. And the next part, we did realizations using two diagrams to do the term frequencies in different subsections of each data source and realize the results using tree map, and this is tree map, and the sunburst diagrams. This is the sunburst diagrams. Please note that the size and the color of each section corresponds to the term frequency in that section, and it's also we can interact with it. And the very last part, we realize the frequencies of different sources using in the XML files, the control access section. So we can clearly see and compare based on these results. Okay, that's all for the overview of this automation tool, and thank you.
Okay, so before we wrap up, I just want to give you a closer look at some of those visualizations that Ella was showing.
Hi everyone, I will just briefly show you how this automation tool works. Basically, it can...
Okay. So there are term frequency visualizations. The initial one we came up with was this, which actually didn't help us that much. What was very interesting, though, was when we used... What this did do, however, was tell us where terms were lacking. So what's interesting about this is that you can see at the left with the special collections, that's SCRC, they didn't use a lot of these terms. So what we actually realized was they weren't putting their subject terms into the finding aids, they were actually putting them into MARC records. So that told us something about their workflow. When we looked at these kind of all aggregated together, it gives us a very clear long tail distribution that looks kind of like a zip distribution, which is common in text data. And we were able to go beyond just visualizing term counts. So this subdivides terms by where they occur in the finding aid and by repository. If you do this in the notebook, you can actually kind of scroll over and it gives you some more information about each one of these term boxes. So they're much more interactive. And then we were also able to see where terms are located. Why would that be important? Because what we realized was a lot of these terms are occurring in controlled elements, right? Which means they're using terms from controlled vocabularies which are outside of the local repositories. So avenues for reparation or repair there would be very different than ones internally, where you could just have a process internally to change the narrative text or to address certain words or to redescribe certain people. So there are a number of use cases. I spoke too long, and I won't go through them in detail, but you will see how we kind of developed these into essentially tables, which we were hoping to use as discussion pieces with potentially source communities. So when you show people kind of a graph of like, here's how many times the term appears, it's kind of useful, but what you really want is to have that as a sort of starting point for a discussion. So these tables where you can see it kind of in context turned out to be, I think, what were the most useful outputs. And so we're kind of finalizing this by figuring out how we can better visualize that and create an output that shows where terms occur and what sentences and in context they occur. And then we're working on updating this to actually work with the archive space API, since at the same time we were doing this, the whole university, the library, and all of these repositories switched over to archive space, and they're no longer basing their data in XML. So we can get the XML outputs, but we want to kind of update this so other people who may be interested to use it can use it with kind of our current systems. So thank you, everyone, and I'll look for questions on Slack.
Thanks for that. All right, the next talk is Corey Halpin, who's going to tell us for 10 minutes about cleaning metadata in bulk through batch editing.
Thank you. That's you? Yep, perfect. Good morning. So a little roadmap of our time together today. I'm going to start off with a little background about who I am, where I'm from, what we do, and the kind of data we work with. Describe a recurring task that we've encountered in our workflow, a tool that we've built to support that task, provide a little demo of that tool, how it looks and works in our infrastructure, and then go through some usage examples of how we've used this tool to improve our lives. I'm a software engineer with the Internet Scout Research Group in the Computer Sciences Department at the University of Wisconsin-Madison. Scout got its start and its name in 1994 with the Scout Report. In the 30 years since then, we've done a whole lot of other projects. The through lines with all of them have been digital repositories, digital archiving, and open educational resources. Metavis is the current incarnation of our open source digital collections platform. It's available under the GNU General Public License version 2, runs on a LAMP stack, and you can find more information about it at metavis.net. Our current largest repository is something called ATE Central. It's built on top of Metavis. We started it in 2009, which was when I joined Scout, so roughly half of our 3 decades has been lived experience for me. ATE Central is an information hub and an archive for the National Science Foundation's Advanced Technological Education Program, ATE. This program provides funding for faculty members at 2-year institutions to develop curriculum supporting technician education in high technology fields. In our repository, we maintain the, in our repository, oh, I didn't know I hadn't been. In our repository, we maintain a catalog of the materials that have been produced with this funding, and also information about the people who've been funded it, and then we serve as the archive for preserving these materials. More information on that at atcentral.net. In maintaining this data, we have repeatedly hit the need for doing repeated edits, similar edits to records across several sets of records. To support that in a systematic way, we built a batch edit plugin for our repository. The way this works in general, you select a set of records to edit by conducting a series of searches, adding the results of those searches to a folder. You define a list of changes that you want for those records by selecting the fields that should be modified, providing operators telling how they should be modified. In vocabulary fields, you can either set terms, clear terms, or just empty the field entirely. In text fields, you can append, prepend, or find and replace. So we can't help with that earlier work because we do find and replace. Then you provide values for those operators, then apply your changes. Little demo of how that works based on our sample records that come with the software. Looking at 2 vocabulary fields in those sample records, one of them being format, which is just this file type based system, and one being resource type, which is using the DCMI type vocabulary. If you wanted all of the things that have an audio format to have the sound resource type, which is easy to demonstrate even though it is incorrect cataloging, you could do that with batch edit, and here's how that would look. You do a search for all of the things with an audio record type, or format rather, in this case FLAC or MP3. You could add them to your folder, navigate into your folder. If you needed to refine the selection of resources in the folder, you could do that by editing it here. Once you're happy with that, the batch edit button will let you specify what changes you want. Add a field. In this case, we'll select resource type from the drop-down of fields, set for the operation, sound for the value to set. You could add other fields here if you needed to, but in this example, we're just doing one. Once we're happy, we apply the changes. And the two records in that sample resource set that didn't already have the sound resource type now have them. So, this tool has made our lives better in a number of ways. One of them, when we add a new field to our collection, it's pretty rare to have a single global default value that you want everywhere, but there will be sets of records with particular defaults that you want. We can use batch edit to apply those. In URL fields, this one might be the most common use we make of it. When our URL checker tells us that someone has changed their domain, changed their content management system so that their files have moved around, but in a predictable way, we can do find and replace to fix those. In text and paragraph fields, we use it for correcting common typos, errors, and inconsistencies. In our descriptions, when we are referencing the name of an organization and we want to change that consistently throughout all of our descriptions, we can do that. In vocabulary fields, we can toggle workflow values to indicate records that need to be maintained. We can add terms as needed, for example, series names to families of records that were not part of a family when they were born, but are now. We can update terms as a vocabulary grows and changes in its use. We had a format vocabulary that initially just had zip as one value in it. We were starting to get IMS common cartridge files. This is basically a fancied up zip format that LMS platforms will use for exporting courses. We initially didn't have a value for that. We added one and then used batch edit to apply it to the records that needed it. We can also use this tool to split values apart into one or more fields as necessary. We had an audience field that was elementary school teacher. We wanted to change that so that the audience would be educator and the education level would be elementary school. We could do that with this batch edit tool. We also use this tool when we're bulk importing records. We have not just records about the curriculum from this program, but also records about the people who produced it. However, these start in 2009. We use these records because we started in 2009. We use these records to drive a product we call the ATE fact sheet. It presents an interactive summary of the program in its current state. We want it to be useful for historical information as well. In order to get that to happen, we need to import the roughly 700 records that started from before we did. We don't want to catalog those manually if we can avoid it. We've identified a number of terms in the descriptions that are indicative of certain subject vocabularies we want applied, and we use our batch edit plugin to apply them so that we don't have to manually catalog all 700 of these records. Another example, in audience fields, which keeps being a problem child for us, we have started work on a new service called STEMlink. This is a way to embed resources that are archived with us in the learning management systems of partner institutions using LTI deep linking. We had to create a new discovery interface for people to find resources within their learning management systems. In doing so, we realized that some of our terms had been inconsistently applied across time, particularly the educator and student terms in our audience vocabulary. We wanted to do some remediation, but only a subset of our records were appearing in this service, and only a subset of our terms needed to be remediated, so we didn't actually need to recatalog everything. We did this with batch edit by creating a new field for the updated values for those terms on those records, identifying the records that needed recataloging, tagging them with one of those workflow fields that I had mentioned before, having our catalogers actually go and do that recataloging into the new field. Then we could use batch edit to clear the problematic terms off of the records that needed to be modified, leaving everything else in place so that we weren't like nuking everything everywhere. And then we could use our plugin to migrate the updated values from the new field into the old field. And with that, I'd like to thank you. There's some links for more information, and we might even have time for a question. Okay. My conference nemesis is... Yeah, my nemesis at conferences is going a little bit too fast, so I'm doing that to help keep us on time. That this was on purpose.
What did you do before you had this?
Well, so our cataloging staff would identify the problem, and then there would be a back and forth discussion with software engineers, and eventually there'd be one-off scripts that would be run to make these modifications. And that wasn't always amazing because it meant that we were running raw SQL against the database and updating data underneath our repository. Not all of the maintenance tasks that needed to be done with that, like updating search indices, would always run because sometimes you'd forget. Putting it into a system where you don't need a developer in the mix, and also you don't forget that bookkeeping, that was much better for us, shockingly.
Uh-huh. All right. Well, thanks, Corey.
Thank you.
Yeah, thank you, Corey. That kind of workflow doesn't ever happen anywhere else, does it? No? Anyway. Okay, next we have a talk from Kirsten Vallee. And the talk is called kwalk, a simple program to crosswalk metadata for repository uploads. Kirsten.
Hey everyone, I am a newcomer to Code4Lib. I missed my applause yesterday because I was getting coffee, earlier, so I needed to get that in today. So I'm here to talk about a program that we've been using in my department, the Center for Digital Scholarship at the University of Chicago. We've been using this program called kwalk that was built in-house in our DLDC department. Figure out, how do we go? So just a little bit about Knowledge at U Chicago. It's our repository that was launched in 2015, and we migrated from DSpace Direct to Tind. And for those of you who don't know about Tind, it is an official CERN spin-off, and all these things that I'm going to be talking about, I've just learned in the last year, so I am by no means an expert. And our metadata is stored in MARC form. And the K in kwalk sadly stands for knowledge and not Kirsten. And knowledge is power. kwalk is built on Refer Tool, which is the program that was built by DLDC, Refer Tool has been in development for 20 years by Keith Waklina, which I probably just butchered his name because I actually never said it out loud. And he is the systems analyst at the University of Chicago. And what Refer Tool is it's a multi-tool for manipulating refer databases. So, actually, yeah, okay. So a scenario where, actually, you know what, let me go here first. The possible data transformations that you can have with Refer Tool, you can rename the fields, rename all fields from invented field names to whatever field names your repository takes. You can add in fields that are missing and exclude fields, combine fields, modify them, and then you can also generate upload URLs. Now let me go back. So scenario where kwalk is useful is, say you need to upload 1,000 items from a source like lens.org or PLOS journals, which are two sources that I recently uploaded to the repository. You will obtain the metadata, say, from scratch, or you export the data, or you web scrape it. So with kwalk, you can apply a crosswalk to that batch of metadata and work with the metadata in a very user-friendly way, like a way that someone like me, who isn't very familiar with many coding languages, would work with data, which is like having a column that says title, an abstract, and the first author 1 and author 2. And you can take that, and with when you apply the crosswalk, it can translate it to mark to upload to the repository. You can also do mark to Dublin core with set up a crosswalk that way. You can take spreadsheet data and do Dublin core. And according to Keith, possibilities are maybe endless. That's how he tells me. You can also mix and match multiple crosswalks on multiple projects. And as I said, transform data, which I already got to. So some useful functions in the kwalk. For example, for a long time, Excel was butchering my dates, and Keith built in a tool so that it would convert just the regular date format of 05/03/2024 to the format I needed for the repository, which is 2024-05/03. Another one is combining literal and field name text. So in this example, the literal text would be spring, and then the field name, you might have various years in the upload data. Also, a very useful example would be as I mentioned, the syntactically correct URLs. You would have the same leading URL here, and then various file names, which you could put in the spreadsheet for upload. So a little quick example of how to kwalk, you would kwalk from CSV to mark. On the left here is a little small, I see, is a crosswalk that I built that has the DOI, has the mark records on the left side and the field names on the right side. And each of these obviously matched to a spreadsheet I was working on that had the DOI, the title, the pub date, and the abstract. All the other little parts in here are items that Tind needs for upload. So, they need me to put that it's a textual item, that it's an article, that it's in English, that it's an article again. I don't understand that duplication, but it's an article again. So those are things that you can build in the crosswalk that you don't have to duplicate in your spreadsheet if you know that they're going to be on every item. And how I run this is, I'm sure all of you know how to open a task management system, most people, and go in there and run this little code that puts together the crosswalk and the CSV file, and then we put out the output. And in that situation, we would get something like this for upload, where the headers have now changed to the mark fields I need, and then all of the items, such as textual, article, English, are now in the file for upload. I gave this presentation a little while ago at the Northeast Institutional Repository Day, and a big question I got was if we can convert from CSV to Dublin core. And yes, you can. The one little addition you have to make is adding these three little operators on the top of the crosswalk so that it translates to the files correctly. So here's what a crosswalk with Dublin core would look like, or from CSV to Dublin core would look like. And once you ran the crosswalk, it would look something like this, where now all of your Dublin core identifiers have data to it, right? And then the next thing is you run this amazing code, and you're able to get an XML file that you can then upload to Tind or your chosen repository. So, yeah, that is what we've been working on for our repository. It's been making things so much easier as someone who doesn't come from knowing many coding languages, like I said. This is the way I think, and I've learned that other people might think the same way, and working with spreadsheets is just a lot easier for people like me. So, yeah, that's it.
So we had another talk that was right on time, so we'll just take questions. Anyone have questions for Kirsten? Excellent, excellent. Well, we can get to our break faster. The next talk is from Matthew Sherman. The title is, Are We Done Yet? The decade-long project of converting an annotated bibliography from print to database. And I'm guessing the answer is no.
Hey, quit trying to steal my thunder. Let me get you out here. Thank you. Hello, all. With 10 minutes, don't have a whole lot of time, so this is going to be kind of high level, but I have been asking this question for a couple of years now. So back in November of 2014, one of my old coworkers, Jesse Sharp, came to me and asked if I thought we could convert this 4-volume annotated bibliography of John Donne scholarship that he found super useful in his PhD dissertation into a database. He was inspired by this other project called the Marlowe Bibliography Online, where they were doing it with Google Sheets, and we were like, we're both librarians. We could do something cooler, right? So we decided to take a look, went over to the Donne Variorum website where they had scans, took a look at it, and see how it's generally pretty well structured. The authors and the bibliographic information were pretty well laid out, and hey, it was OCR'd. So we could potentially manipulate that, and so we thought, yeah, we'll give it a go. And so Jesse went to the Donne Society, asked permission because they own the copyright. So it's kind of a good idea to get permission to do this stuff. And after a couple of months, he got permission, and we met together with Brent Nelson at the University of Saskatchewan, who's sort of pretty also heavily involved in the Donne Society. And he, back in 2010, had some grad students he worked with to clean up the OCR, so it wasn't just your usual sort of textual jank that we expect from 2010's OCR. And so we had something nicely proofed and formatted to work with. And so when we sat down with Brent, we noticed a couple of obvious issues up front, because still, even with that nice clean OCR, we're dealing with OCR text. There's still going to be weird little bits and bobs that show up, and that's going to mess with what we can do. We're trying to convert unstructured text, just the characters in a file, into something at least semi-structured enough to like jam into a couple of fields so a computer can at least throw it up in the correct part of the page. On top of that, we're processing over 5,000 records over the course of 4 volumes, which each of which have over 1,000 records a pop, and so that's a lot of work to do, especially for a 2-man team, neither of which can do this on the clock because our employers weren't, letting us do our own side projects. So yeah, that's a lot of work for not a lot of time to work with it. And then even once we got all of that put together, we had to have some system to put it in. But we'll start at the beginning and actually try and make some conversions. So talking it over with Brent, he suggested rightly that we look into regex, because regular expressions and all the pattern matching it does is great for doing a lot of processing in bulk. Of course, neither of us being programmers and had never used regex before meant had to learn regex. Thankfully, this community was super helpful in providing resources of places to go look. And over a couple of months, I pounded away, sort of learned, figured it out, and then kind of learned the zen of regex, as well as large projects in general, where I was trying to make the regular expressions select exactly the thing I wanted to do, like the author or the title, and then I realized, wait a second, I don't need to select those. I just need to select the spots between those and jam a delimiter in there, which when we look at the number of special characters in here, was going to be a tab, because CSV would have been escape hell. We made a go of it, and actually worked pretty well. It did take multiple passes, because we had to do different sort of expressions to catch everything. But it was enough to throw it into an Excel file, and then we could actually see where things didn't work right. We could manipulate it, recognize that, oh, hey, the year as a header for a field isn't going to be very helpful in records, so move that around, made some mistakes that we were going to have to fix later. But it actually ended up working pretty well, and over the course of a little over a year, we got the first volume into a data format, at which point it's like, great, now let's figure out how we display this. So tried a few things, was able to export it into an XML file, even got it into a SQLite database, but after that, we didn't have the resources to really do anything more, and so it just sort of languished as we piddled along with the following volumes. And it sort of set into a sleepy season. But behind the scenes, Brent was bringing some of our work to his folks at the University of Saskatchewan and asking, hey, is there something you guys at the Digital Research Center could maybe put into a Drupal site, because they're a Drupal shop. And turns out the Canadians came to our rescue, because Brent was able to get an Inc. grant in about 2021 for a variety of different John Donne digital scholarship projects, and he brought us along with him, which is great because he has access to resources at the University of Saskatchewan, like graduate students and researchers that can help do processing work, a developer who can actually code stuff, servers. So it was great, and we were able to get the Digital Research Center's developer, Ahmed, on the project, and he was actually able to spool up a Drupal instance for us in Drupal 9, and was able to use YAML for sort of the actual record formatting and upload things with Drush. So it's great. We have something that actually exists, which didn't necessarily make the process of making everything else happen any easier, because we had volume 1, which had to have some remediation. But it turns out OCR in each volume is a little different. Slightly different formatting. You can see how, oh, ... 1 to $1, that's going to be a problem. And volume 4 was purely born digital in a 2-column PDF. So trying to actually make that text line up correctly required a lot of handwork by some really great grad assistants to actually make things usable. But we were able to use the process we piloted to actually do the processing for that, and are able to then bring it all together into one big old spreadsheet for the upload, so that we're also able to use that to recognize things where, like, oh, we need to add some additional fields to get some more useful data to work with. Similarly, it allowed us to increase functionality, because one of the other things we wanted to do was actually make the indices in the back of the book usable in a search function. And that required us to port out the indices from the back and sort of create that data in lookup tables to be uploaded alongside, so that they could cross-reference in Drupal. And it actually ended up working pretty well and gave us some additional flexibility to have like indices for things by just clicking on the author and then seeing all the various records and fields. And some of the things involved to make this work required a bucket load of coding on Ahmed's side. Things as simple as retaining the italics had a surprising amount of PHP required for him to make it work, but it's nearly a real thing. So to answer the question, are we done yet? Not yet, but we're actually getting pretty close. The last 2 volumes of data are almost done processing, but it needs a little bit more. Once that's happened, though, it can be added to the table, added. So once that's online, then we actually have to turn production on. This is somewhat held up by the fact that Ahmed took a different role at USask, and now we have to read a new developer in, so the perpetual life of library and digital humanities development. But the new person seems pretty good, and we have some future functionality ideas. So we're not done yet, but we're getting close. So thank you all for your time.
So I think the fact that there's a raging debate in the Slack between Team Regex and Team Regex suggests that it's time for the morning break. So go and enjoy some coffee and tea and visit with the exhibitors who are sitting out there at tables wanting to talk to you. If you are doing a lightning talk, make sure they start immediately after the break. And you need to have, if you're using slides, you need to have them up on this computer. So come up during break to put them on. Okay. Go break.
Yes.
Check, check. Check. Check, check.
5-minute warning, everyone. All right, we're going to get started in a minute. So maybe some calisthenics to warm us up again. Okay, I have another question for you. If you are working on or thinking about AI, raise your hand. See, I had this idea, if we could replace the I with AI, and then we would be Code4Lib, and we would not have the arguments we do, right? Is anybody still working on blockchain? Yeah, okay. All right, let's get started. The first talk is from Jonathan Rochkind.
Hello, I'm Jonathan Rochkind. I work at the Science History Institute. I'm going to try to do a little live demo. I'm going to try to get the mic pointed at my face. That seems like it's working. So, we have a little locally developed like page viewer. Like a lot of people use Universal Viewer or Mirador, but we have our own local one I just wanted to show you because I think it's cool. And there's just, it's a zooming page viewer. Here's thumbnails of all the pages in this book. You can pick them, and you can zoom in to our high-resolution images, and you can say, next page. You can zoom. And this is all OpenCDragon, which is the same open-source JavaScript component used in Mirador or Universal Viewer. And it's just really mature, good, polished code. It's really easy to work with. So it's really doing all the heavy lifting here. And this was a lot less JavaScript than you might think. And it also looks really good on your phone, responsive, right? Imagine this is a phone. We have the pages down here. We can still do everything we can do. Universal Viewer sometimes works, I'm not sure, it might depend on the version, but I've seen it work differently on phones. And I think we just, this was easier than you might think. And I think sometimes when we stick with Universal Viewer or something like that, because it's so hard, because it works for everybody and it's this big software, it kind of, the user experience stays a little bit static. And I think our users really deserve us trying to give them a really polished experience that is as good as other fancy stuff on the internet. So we also, recently, it isn't quite as done as I thought, but we added, search with highlighting results from OCR, which at first I thought, well, that's going to be too complicated. I'll probably have to switch to Universal Viewer for that. But it ended up being not that complicated because OpenCDragon is so easy to work with, and we had the OCR anyway, so. And this isn't quite finished yet. There's more features coming, but OpenCDragon basically has UI to put these highlights on, and we can flip the thing around. This is all courtesy of OpenSeaDragon. We have our own downloads integrated in here. We can really customize this for our content and our use cases. The search isn't really done. There's more stuff coming, like next previous step through the search results and better like highlighting of your current one and where they are in these pages and stuff. I hoped to get that done before the conference, but I didn't. We have a little search box on the main page, so when people get here from your search results, you can immediately see, oh, this is searchable, and you can search there, and it just pulls this up with your search results. So yeah, that's pretty much it. I just wanted, this was, what makes this doable was developed for our stuff. So I'm not encouraging you to use this code. I'm encouraging you to consider, whether with the viewer or other stuff, consider sometimes experimentally trying to do something yourself, just to see, when we have other examples, we can get other ideas for UI that maybe will filter back into other things, as opposed to when we're all using kind of a monoculture of the same thing. Like I said, I think sometimes the user experience can get a little bit frozen, and we're not actually pushing it forward for users. And sometimes when we experiment with our own stuff, we can make, I think this looks really nice. And I think like for us, where I work, a fairly small nonprofit, trying to look like we're really professional, like really helps us, right? People are like, oh, this isn't some jury-rigged weird thing. This is like people that really know what they're doing. And I think it makes it easier on the users using the stuff too. And that's all, I just wanted to show you that. I think it's cool. I have another minute that I won't use all of while I just click on random pages. And that's all. Thanks.
That was cool. Thanks, Jonathan. Okay, Jenn Colt.
We saved it earlier.
Yeah.
Okay, here.
Oh, over there. LT FOLIO, yep.
Awesome.
Thank you. Okay, I'm Jenn Colt. I'm from Cornell University, and my lightning talk is FOLIO. It's not just ... So to start with what FOLIO is, it is an open source library services platform that provides a bunch of the functions you need to run a library in the like traditional library sense, not a digital repository sense. And about 200 libraries have adopted it. The website is folio.org if you want to look at it yourself. So EBSCO, who sponsors Code4Lib, yay, also sponsors a lot of FOLIO development, which is also yay. But sometimes when I talk to people about FOLIO, the response I get is, well, that's just EBSCO's, right? And so today I want to talk about the big community behind FOLIO that is more than just them. That involves a lot of libraries, other vendors, and just like a ton of great people, and maybe encourage you to consider getting involved with FOLIO, and maybe especially on the technical sort of code development side. So the FOLIO community outside of code development for a minute, there is a large community of subject matter experts from libraries, and they help define requirements, they do testing, they write documentation, they do a ton of work. There are also, sorry about the ums, there are also a lot of library workers who participate in the governance of the FOLIO project. We have 3 governing councils, a product council, technical council, and community council. I'm on the technical council, and I know there are a couple other of us wandering around this conference. And so in addition to that work, over on the code development side, we also have library workers involved, but it would be great to see more. So here's a slide of our FOLIO development teams. You'd be in great company if you were to join us. Just some specific institutions: Texas A&M, University of Alabama, Cornell, Lehigh, National Library of Australia, Mainz University Library, GBV, VZG, and ZBW in Germany have all contributed code to FOLIO at different times and in different ways. And there are others that I have not named who've done so as well. So there's a lot of different ways that this development work by libraries can get done. Some institutions, like the ones I was just talking about, they have their own developers and they contribute their time, and that's fabulous. So if you are a developer or you support developers at your institution and can help them make time that they get paid for, then we would love to have you consider doing that for Folio. It's Java on the back end and JavaScript on the front end is what you'd be looking at. For libraries that don't have internal developer time, sometimes they sponsor development through the vendor that hosts their Folio. And sometimes libraries come together in a group and fund some development that they want to have happen. And all of these pathways have been successful ways for libraries to help determine Folio development. So as far as the kind of development they're doing, sometimes they're just adding like a little tweak, some small improvement. Sometimes they're building like a great new feature, and sometimes it's a whole new module. So like the University of Alabama worked on Folio's calendar system. Earlier on in the project, a group of libraries got together to fund development to work with OCLC, and right now Texas A&M is building a whole new module to deal with workflows. So those were all cases where libraries saw something they wanted to do, and they did it, or are doing it, and it was great. So again, I'm hoping today to get you to consider getting involved in Folio development. I want to point out that we're doing a couple things to make it easier. We just hired a developer advocate, and part of his job is to hopefully help new Folio developers along, and we're super excited about that. And we also have some architectural changes in the works that we're hoping will help people get their changes to production faster. So it might be that you thought, because Folio had so much vendor support, that we didn't need you, but we totally do. The involvement of library workers is really important for Folio's success. Nobody in Folio wants to go it alone. Folio, like on the first slide, can I go back, says that it's a system designed by libraries for libraries, and we are the library workers that can hold them to that promise and make sure that software that's integral to libraries reflects our values and who we are. Thanks.
All right, next we have Vera. Is Folio going to do a breakout, you think?
I'll be there.
All right. Vera.
Hey everybody, my name is Vera. I'm going to pull up my slides. So I'm here to talk today about Rafat al-Arir, a Palestinian poet who was murdered in an Israeli airstrike on December 6, 2023. And I'm also here to talk about protest as archive space. I'm really interested in how there's this oral archive of chants and songs, and that, you know, I remember there's chants that I learned on the streets that I then years later read about in history books, not even realizing that I was, you know, part of this oral tradition. Another side of that is sort of print, if you will, sort of graffiti, memes that are, you know, replicated throughout the world. And so he wrote this poem just before he died about, the first line of which is, "If I must die, you must live to tell my story." And within like 2 days, this was all over New York City. It was all over protests. If you can't read it, it's a little messy. It says, "If I must die, you must tell my story." You can see there's patches, people wear patches, there's t-shirts, there's graffiti, there's posters, it's everywhere. And this to me felt different than a lot of the sort of memes and graffiti that you see from, even from the same movements. And so I started thinking about like what was so different about these words that they became this, that they so quickly spread. And I realized it's an if statement, it's a conditional statement. And the human compilers who heard this poem, you know, they didn't realize it, but they were executing a program, this poem program that this man wrote just before he died. If I must die, you must live to tell my story. And at first, when I was thinking about this lightning talk, I was like, oh, it's like recursive maybe, because, you know, like he said it and then we do it, and then I guess, you know, theoretically, if I die, then someone else will tell my story. But the more I thought about it, the more I realized that it's actually like a virus, and that's actually what makes it so powerful, is that, you know, when I see this, I feel taken to the call, and I become a part of the poem program that is then going to transmit it to all of you and the rest of the world. So, rest in peace, Rafat Al-Arir.
Thank you. Next is Shinwoo Kim.
This one's you? Yes. Thank you. You're all set. Hi, I am Shinwoo Kim, an application developer from Cornell University Library. Our data in our preservation repository has outgrown our digital preservation system. We currently have 3 separate storage instances, around 150 terabytes each. The Fixity job on a single process that used to take a few days on a single instance now takes more than 40 days. As part of our all-cloud migration effort, we decided to take full advantage of cloud storage and run Fixity process in parallel. So we start out with a container implementation. With 33 containers, the job that used to take more than 30 days, now finished in 1.5 days. But we were hit with a surprise network charge because the containers were running inside private VPC. All the traffic had to go through network address translation gateway or net gateway, and that charge ended up hefty. We decided to use Lambda instead because there's no extra network charge if the traffic is through public internet. Our data has files that range from tiny text files to more than 200 gigabyte video files. And Lambda has hard limit of 15-minute maximum runtime. This poses a problem for us. The larger files don't finish within 15 minutes. Fortunately, some very smart people have figured out how to resume SHA checksum with Python as far back as in 2014. Basically, you load OpenSSLC library and interact with it directly inside Python. So we rely heavily on relational database for the concurrency and fault tolerance. We ran 100 concurrent Lambda functions per cloud instance, and the job finished in less than half a day. We still have lots of headroom for growth. We can run up to 1,000 concurrent Lambda functions. The total Lambda execution cost was less than 1/100th of the container approach. Thank you. Cut your cost by a factor of 100. Wow.
Okay, next is Eric Lease Morgan.
Good morning. Thank you. I would like to give you folks access to CPUs and GPUs. Okay, I'm going to say that again. I would like to give you folks access to CPUs and GPUs, specifically to do AI. I have recently been granted an AWS sponsorship. The sponsorship is more or less carte blanche. I can fire up any kinds of machines that I want to. I fired up 128 core machines and played with those. I fired up HPC machine system with like 64 nodes, and each node has 32 cores, and I just compute against the whole thing. I can bring up machines with 64 cores and 4 GPUs and do whatever it is I want to do. I take this back. If you are doing some sort of AI something, and you are doing something in libraries, and you are limited because you don't have enough hardware, or maybe you would like to use some sort of Amazon services like SageMaker or Bedrock or a few other sorts of things, then let's chat. It's entirely possible that we can work together and you will be able to do your thing for a limited period of time. And I'm just here to say that I would like to share, I would like to collaborate, And again, if you need some hardware or a platform to do some of your work, then come visit me and we'll see what we can do. Thank you very much. Oh, wait a minute. Do I have time? There's no clock. Oh, great. Are there any questions? And I can stand here for 3 minutes. All right, I'm being ticked off the stage. Thank you very much.
Thank you, Eric. Yeah, talk to him in the hallway. Next is Cary Gordon.
I've got nothing. I am my slide. Okay, so my name is Cary Gordon, recently retired library technology hired gun. And I'm here to talk about Code4Lib 2025. Where will it be? Frequently asked question. So for the newbies in the crowd, there is no Code4Lib organization. There's no management, no formal structure. It's just a bunch of volunteers. We have a fiscal agent, thank goodness. We've had it for a few years, clear. And we frequently, almost always, use the services of Concentra, who is a conference management company who are managing this conference. Everything is run by volunteers. And at this point, I'm just going to make my plea. We need people, we need institutions to step up to offer to host next year. It may seem like a daunting task. It's a semi-daunting task, but it's certainly doable. We provide lots of experienced folks. Like I say, Concentra is certainly a highly recommended option. We have the power of momentum, and we need you to go back to whoever the powers that be, or maybe if you are the power that is, to just put something forward. So tomorrow, Jenn Cummings from Concentra is going to be doing a breakout on doing a Code4Lib, and please come. Even if you aren't directly involved, if you are a person who could put a bug in somebody's ear or, a gun to somebody's head, I didn't say that, please do it, because there will be no conference next year unless somebody steps up to do it. That's all I got.
And thanks to everyone who has contributed by organizing a conference in the past. Next is Barbara Cormack.
Yes, you do. How's the volume? Good? Great.
That's you.
Yeah. And keys go down. Okay. Great. Great. Hi, everyone. My name's Barbara Cormack, and I'm not a Code4Lib newcomer, but this is the first time I've gotten up and talked in front of so many people. So I'm going to talk to you about metadata analysis in Zephir and HathiTrust, and in case you don't know about those things, I will tell you about them, and thus expose my terrible lack of slide creation skills. So I am the Senior Metadata Analyst for the Discovery and Delivery team at the California Digital Library, and there's a few factoids about me in the bullet points. And what is Zephir, you may be asking? It is the metadata management system for the HathiTrust digital library, and I've included some handy factoids there about HathiTrust. But the thing to take away from it is it's really big and it has millions of records. So I want to talk to you about metadata analysis in relation to all of this. And so what's it all about? So we have contributing members who send us bibliographic metadata records, and they submit them to the Zephir system for ingest. The records have to meet a certain profile that we work out between us, and they have to meet certain requirements. So my job is to analyze the records and make sure that they fit that profile. And if they don't fit it, well, that's a story. So I'm going to talk briefly this morning about what I look for in those records that are destined for Zephir and HathiTrust. So here's how it works. So HathiTrust has many members, but there's just a subset of them that are contributing members who provide the MARC records that end up in the catalog. So what do? They can send us MARC or MARC XML files. The files have to be correctly formatted. We have to be able to convert them and do things to them. And if they don't match our validation processes and stuff, things get weird. So what I do is I take those files and I convert them to a text-like format using something like MarcEdit, or sometimes I use UltraEdit to do some validation. And I have sort of a shopping list of things that I look for that I start moseying around in the data. So what are those things? So first, I start browsing through the leaders. So I want to get a sense of what kind of records I have. So I'm kind of honing in on the leaders 6 and 7 to see, mostly I'm looking for, have I got a lot of monographs, or have I got a lot of serials, or have I got something else in those records? I'll look at the leader 9 to see if it's got that A code that says, I claim that I am sending you Unicode or UTF-8 encoded records. And I'll scroll through the records and see if they have diacritics. And are the diacritics looking good, or are they maybe a little bit munged, which happens sometimes. And again, I'm just going to scroll. I'm going to eyeball that data. Okay. We expect people to send us print records, so I'm looking for indicators that they have actually done that. So I'm looking in the 00823 for that O for online. I'm looking for the 33X fields that look for media type, has the word computer in it, karyotype has something like online resource. If they've got 655 genre subject fields, I'm looking for that word electronic. If they've got 776 linking fields, are they pointing to anything besides print? Because that would be bad. I need unique system identifiers in the record at the bib record level, usually supplied by the system that the records were exported from. Could be a utility number like OCLC. And the reason I focus on those so much is that Zephir clusters records together, and it most often does those using OCLC numbers, but it can also use system numbers like ILS numbers, like an MMS ID from ALMA or something like that. Okay, speaking of OCLC numbers, I spend a lot of time looking for and looking at OCLC numbers, if the library even uses OCLC. So I'm looking, where are those things? Are they in the 035 or the 001? How are they formatted? Do they have prefixes? Does a record have more than one OCLC number? Does it have no OCLC numbers? If they have more than one, are they in the same MARC field? Because that could be complicated. And I might even look around to see if they have any 079 fields. Finally, every bib record submitted to Zephir has to have what we call a volume field that describes some information about the entity that's been digitized. Most crucially, it needs to have a unique identifier such as a barcode or an ARC or maybe some kind of accession number. And if it's got some enumeration and chronology information, that is also great. So that's a quick romp through metadata analysis for Zephir, and thank you so much. This is the traditional ending with a picture of my cat who is making her next reading selection from one of my bookcases. Thank you.
Thank you, Barbara. And now to finish up our lightning talk selection, we have Natasha Allen.
I'm Natasha Allen, pronouns are she, her. All right, so I'm here to talk about fowling. So who has heard of fowling prior to looking at tonight's networking dinner section on the website? Like 2 people, okay. So I'm guessing that of those 2, probably one of you have actually played it. I know you have, okay. Well, you're about to, so let's clear some space in the middle of the room. I'm just kidding. Some facts about fowling. It is not to be confused with the sport of fowling, which involves hunting birds, and as a vegetarian, I have to just respectfully say no to that. It was invented by Detroiters tailgating at the Indy 500 in the year 2000. In the great American tradition of making up games to play during the course of drinking alcohol. The first fowling warehouse was created in Detroit. It has spread to other cities in Michigan, Ohio, Indiana, Kansas, Missouri, Texas, Nebraska, and Georgia, probably elsewhere too, but I just needed to stop there. I only have 5 minutes. So now I'm going to show you a quick 2-minute video to explain how it works so you can be a little bit more prepared for tonight.
Hey, welcome to Fowling. I'm Chris Sutton. Here's the rules to the game. 2 teams. A team can be up to 5 players. Could be 3 against 5 or whatever combination you'd like. 1 football per game. The object of our game is to knock down your opponent's pins before they knock down your pins, throwing the one ball back and forth. Overhand, underhand, it can bounce, it can roll. No kicking. And we continue throwing back and forth until one team has knocked down all 10 pins first. Team 1 knocks the pins down first. Team 2 gets that rebuttal. If the rebuttal is successful, overtime. Overtime rules are each team sets up 1 pin on any dot they choose, flip a coin, and the winning team takes the ball. Overtime is sudden death. First pin down wins, no rebuttal. At the end of the game, you set up your pins and you switch sides. You can win the game on one throw by A, throwing a strike, or B, throwing a pawn. Any player on their first throw of the game, if all 10 pins are still standing for them, if you can hit the 5 pin and only the 5 pin off the board, that's a bunk and you win the game. Team 1 throws a strike or a bunk, Team 2 still has the rebuttal, but good luck. That's tough to follow that up. Remove all the pins that have been knocked down off the floor, off the board, and we put them back to the fence. Behind the board is the pro line, up to the front of the board is the amateur line. During the game of fowling, you may not stop your ball from hitting the pins in front of your pro line. All the other footballs from the other games count once your game starts. You are allowed to play defense on those. You just have to pay attention. End of the game, set up your pins, and you switch sides. And the losing team or the new challengers always throw first in the next game, giving the winners rebuttal, last throw. And don't forget to check fowlingwarehouse.com for a fowling location near you, where you can get information on your party, your event. You can participate in a tournament, or even join one of our leagues. Now that we've learned all the rules of fowling, it's time to flip that coin, get the game started, and fowl on.
So there you have it. Hopefully, I guess I'll see you there. As a collector of weird sports, ask me about hurling sometimes, the national sport of Ireland. I am a player of that. Anyway, as a collector of weird sports, this is right up my alley. So enjoy it, and hopefully we'll see you tonight. Thanks.
Bowling. That's going to be so much fun. And no knuckleheads. Okay. So let's give a good applause for all of the lightning talkers, especially our first-time lightning talkers. I think they're the best part of the whole conference. I don't know, but we also have had a good set of lightning talkers who finished under time. Thanks, Eric, especially. And so now we can move on to the next group of talks so that we can break early for lunch. All right, so we have an in-person talk for 10 minutes from Sarang Joshi, OCR and PDFs, the possibilities and limitations for accessibility. I'm very interested in this talk. Are you coming? Yeah. He's gonna make it. All right.
Should not have started out in the back.
Do you want full screen?
Yeah. Cool. My name's Sarang. I'm a software engineer at the New York Public Library. Going to talk about some of our digitization efforts and how they've kind of fallen somewhat short in some places. So a quick overview. I'm going to talk about the impetus for the work I've done, this publisher backlist project. I'll talk about what we did, and then those limitations we ran into. The New York Publishers Project, we've been working with a variety of publishers, mostly university presses, to digitize and serve backlist titles. So these are titles that have not been in print for a very long time. They haven't been digitized before. And the publishers kind of just want to know which one of these are useful to them, which could they put back in circulation. So in exchange for giving us rights to these works, we can provide them data on their usage, downloads, stuff like that. So this is kind of like the operational overview of how this works. The publisher sends us titles. We scan the images, I think using automated image scanners, I'm not sure. We send these off to Google. They do all of the OCR for us. So they use optical character recognition, extract the text, send us a big bucket of files, and then we kind of glue everything together and serve them on our digital research book site, which is just it's like an index we maintain of research materials that have been digitized from a variety of different sources. I'm not sure if they're actually on there right now because we've run into some hiccups along the way, but that's the intention. So this is basically what the process looks like for generating these PDFs. So from the OCR process, we get back a METS file containing all the metadata about the book, and then we get a zip file containing just a bunch of, containing all the image scans, and then an OCR file corresponding to each image or each page on the PDF. And we run it through a little data pipeline we created, just a set of short-lived Python processes. So first we take the text, we overlay it on the image. We do some extra processing to get some more structural elements. So we actually get things like chapter headings and like semantic page numbers as opposed to just the index of the page in the PDF, just to make it a little more usable. And then we also add in some metadata and then serve that. And this is an example of what the metadata looks like. So this is the METS file. This is an entry for a single page on the file. You can see it has a label corresponding to some structural information. This is the start of a chapter. We have the order label, which corresponds to the semantic page number, and then the corresponding files. So an image file for this image scan, an HTML or XML file for the OCR data. And then this is what the OCR file looks like. It's just a bunch of words with a set of coordinates. This is where the word goes on the page, and we just map it onto the page. There's some open source tools that we use to do this, but sometimes, depending on the format of the, we get a variety of formats for the OCR data. Sometimes we have to hand draw. And so this is kind of an example of like a nice case of like a successful case. So this is a portion of a page. We get like a page label that's accurate, which is nice. We get an accurate chapter marking, which we can annotate in the PDF to make for, easy navigation. And the text is generally actually in a pretty standardized font. The quality of the scans is really good. So actually, we've observed the OCR data is both good at identifying the text and mapping it in the right place. So that's kind of like the nice case. There are some limitations to this. So kind of a small one, but somewhat annoying, is a lot of times these chapter labels are just inferred by the OCR process. They're not very smart, so we get a lot of inaccurate chapter headings. So in this example, this header appears on every page in the book, and that's not a very useful heading for navigation. The bigger issue, which is we don't really have a solution for at the moment, is a lot of these works are we envision them being used as research materials, and they contain a lot of images, figures, stuff like that, charts that might not be, that won't be usable by somebody with a screen reader. So this page is literally just an image with a caption. Generally, we're able to OCR the captions, but to somebody who can't see the page, this is just going to show up as a caption on a page. We don't know there's an image there, and we don't have a description of the image. So we've looked into a couple solutions. Truth be told, we haven't successfully implemented anything, so if anybody has any ideas, talk to me. But one is we've worked with vendors to just ask them through their black box, don't really know what they're doing, but we send them a bunch of alt text and ask them, hey, can you just describe it? I guess predictably this didn't go well. There's the people writing the alt text descriptions are not necessarily experts on the material. They don't have a ton of context. It's also very expensive for the quality that we get. A thing we haven't had time to look into, but we would love to try, is large language models. We could potentially feed them context of the surrounding text, since we have all of the text of the work. We are skeptical of it. I think there's a talk after this that might expand on that, actually. But we're skeptical for a few reasons. One, similar quality concerns. Well, the other thing is, like, we specifically, not just the library, but like our digital department at the library, we not necessarily want to dive into the realm of like creating content, which is kind of how we look at generating these image descriptions, because the author put the image on there for a reason, and we might not be able to have the context to generate, to just convey what the author was trying to convey. And the second thing we've kind of learned is, scalability is not the be-all, end-all. We might better serve our patrons by having some sort of manual process, so technology is not always the solution to every problem. And yeah, that is about it. Come accost me if you want to talk about this more. That's my email address. This GitHub repo is actually private, I just figured out, but I have a prototype. If you search PDF Jenn prototype, and I can link that somewhere. Thank you.
All right, our next talk is from Christina Cutler, and the title is Creating Accessible Documents as Non-Authors, Tools, Strategies, and the False Idol of AI.
This room is really big from over here. Is this one? Is that one you? No, that's not me. That is a good joke. This one? Yeah, okay. Awesome. Hi, everybody. Let me adjust that for my height. Hi, everybody. For the requisite claps, I am a first-timer. And this is actually my first in-person conference ever. So I am a little sweaty right now. So I'm going to be talking about creating accessible documents as non-authors, and I missed the part where we were supposed to do a case study. This is more of a literature review. And also, even though it says documents, I'm going to be focusing on PDFs because they cause a ton of accessibility issues, as I'm sure most of you know. Okay, so the context. I used to work as a student librarian, uploading documents for my institutional repository. Part of my workflow was remediating deposits for accessibility, which was not required and I was not trained very well on how to do. And it was by far the most time-intensive part of my workflow. To try to speed it up, I did a literature review. Although I finished that contract job before I could enact any changes at that institutional repository, but that's why I'm sharing my ideas with all of you. I was focused on institutional repositories because that's where I was working, but I think the findings here are more general to anyone dealing with PDF content, particularly if you're still uploading new stuff. I am especially concerned about graduate theses and dissertations, where a single PDF is often the only copy that exists. So if you work with theses and dissertations, I want to talk to you. Also, I'm going to be focusing on PDFs, and the users I'll focus on is screen reader users. Oh, whoops. Although obviously other forms of print disabilities are important, but I'm going to focus on screen reader users. Here's what I'm going to talk about. First, I'm going to define the problem and talk about what are, in my opinion, the most important issues in PDF accessibility that you should focus on and think about. And I'm not going to talk about WCAG at all. That's not our goal. WCAG compliance is really complex. We're aiming for simple things that you can do simply. Second, I'm going to look at strategies for making better PDFs, looking at some successes and some failures, mostly looking at tools and some AI tools. I'm going to lay it out. Third, I'm going to lay it out all real simple and give my suggestions for what you can do to improve your document's accessibility. Okay, here are the key takeaways you can think about during the presentation. Number one, accessibility work can be simple. Number two, AI tools can't fix the problem, but they can help. And number three, PDF is awful. And if the only thing people get from this talk is that you should think about moving away from using PDFs, I will feel very successful. Another quick note before we go on. I am not a screen reader user. I have maybe 10 hours of experience working with a screen reader under my belt for extremely ad hoc website auditing I've done, and that's a major limitation. To account for that as much as possible, I've tried to reference studies that have user testing to make up for my lack of lived experience. Come on, next slide. Thank you. Okay, so let's define the problem. What are the main issues for PDF accessibility, in my opinion? Well, you're in luck. I made a handy-dandy table. There are so many accessibility requirements for PDF. If you want a fuller list, you can look at PDF UA or WCAG PDF techniques, but the most essential thing for PDF accessibility is having real and correct text in the right order. If nothing else, add that. The next most important pieces are skimmability features like bookmarks that was talked about. Also having correctly tagged tables. Then finally, there's the really hard but also important stuff like alt text and real embedded math. And last, there is a lot of nice to have features like author and title metadata and very specific tagging things for things like lists and links. I'm going to focus up especially on accessible math, because inaccessible math isn't talked about enough, and it creates barriers to basically every single financial and STEM field, not just pure math fields. So let's go through these unique issues a little more slowly so we can address how to mitigate them. Okay, first, I think we all know that having real embedded text is a problem for scanned documents, but this also happens when anyone clicks print to PDF, which researchers are doing, instead of properly exporting to PDF from their source file. You'll have real text if you just click Save As, but better yet, you can save as PDF from Word with all the accessibility intact if you click the right submenu options in Word. A link to a guide on how to do that is in my slide notes, and I hope someone shares that on Slack. But if you already have legacy PDFs without text, then you can reference any of the other wonderful talks from the week talking about OCR. Because for typed documents with good scans, OCR
mostly works. Not older kind of typewriter, typewritten documents, but if it was a print to PDF document, it works pretty well in my experience and in many people's experience. Okay, so it's obviously important for screen readers to have text to read, but what if, like most folks, they never read whole articles and just want to skim them? They do that with headings and bookmarks, of course. Authors still often neglect to include this in a structural way, still adding them by changing fonts manually. Adding headings and bookmarks by hand is a pain, and the way that you do that in Acrobat Pro is with the reading order panel over here, which lets you tag content, but that takes forever. There do also exist some pretty great tools that can automatically add headers, including Acrobat Pro's auto tagger tool. Those still occasionally mess up, especially with odd formats. But on the whole, they, in my experience, work pretty well if you're interested in them. Okay. Tables are often auto-tagged correctly and can be automatically detected unless there's a bunch of split and merged cells and multiple headings, and obviously if it's an older scanned document, it also struggles. AI tools do a terrible job of deciphering complex tables like this, and it takes hours, actual hours, to clean up and tag by hand. Again, if authors properly export Word documents and other source files, this problem goes away. But speaking of complex things that nobody likes doing, let's talk about math. The gatekeeper of STEM fields. This is basically always an issue, and I'll explain why. The PDF standard, by default, can't have properly stored LaTeX code. It can store MathML, the HTML math standard, but extremely few researchers, especially in math-heavy fields like physics and engineering, actually use MathML. So we'll keep talking about LaTeX. There are projects and extensions that try to embed LaTeX markup directly into a PDF, and most screen reader users who work with high-level math know LaTeX, and compared to lots of alternatives, it can sometimes even be their highest preference to work with, is raw LaTeX code. So this works, but this still is not a great solution. You can imagine a first-year undergraduate student who's blind or has low vision. They'd have to learn LaTeX before they can even start reading their physics textbook, assuming they can even get the textbook in LaTeX. The alternative, getting screen readers to read math notation as if it were real natural language, is a completely subjective problem, though. How would you read this equation on the screen, for instance? It totally depends on who you're talking to. Are they a beginner, an outsider, or an expert? You would need to include different levels of detail for each of them. So, math in PDF is a genuine nightmare for blind and low vision readers. But the other genuine nightmare is alt text. Alt text is one of the biggest accessibility talking points out there, and I think trips a lot of people up, which is why there's so little of it out there. Authors aren't putting it in, most publishers aren't requiring it. But most images in research articles or theses are really complex and require high subject-specific knowledge to correctly interpret. So a third party can't add the alt text. No individual can do it for every academic field, as was just talked about. And AI definitely has not come far enough yet to be trusted to correctly interpret a graph from a master's level biology thesis. However, the other trick is that although accessibility standards say every image needs alt text most of the time, you don't need complicated alt text if the figure is described in the text. If the article includes all relevant information from the figure, the alt text can just be a name like figure 1. That's actually best practice. Both screen reader users and most sighted users prefer for figures to be described in the text, so that's a win-win solution. This suggests that the best option for improving figure accessibility is to encourage authors to interpret their figures in the main body of the text, both as an accessibility improvement and to better engage all readers. Okay, so those were the accessibility problems. I hope you're all still with me. That was a lot of information to throw at you. This part should be more fun. Let's talk about some of the suggested solutions that I looked at to try and solve some of these problems. Some of them work, and some of them have real-life examples, and some of them really don't work. Okay, so
you can work through some of your backlog by hand with student work. Particularly if you make a short list of priority documents, your 50 highest used ones perhaps, at least it's a start. So really quick, I, as a student, using Acrobat Pro's automatic tools and some hand fixing, could remediate PDF for about $1.25 per page, which is like $1 per page in American dollars. For contrast, on another project I helped with, which looked at PDF finding aids, a vendor said they could remediate for about $22 per page, but they could create WCAG-compliant documents. But that's obviously way out of almost anyone's price range. But still, as non-authors, neither of us can produce adequate subject-specific alt text for figures and math. So neither of us can fully complete accessibility requirements. Okay, another option. I know a lot of you deal with platforms and you can talk to your users. So let's nudge authors in the right direction. Authors often don't make accessible documents because it takes time and there's a lack of awareness of the need. To nudge them in the right direction, there are 3 major things you can do. Bare minimum, communicate the importance of exporting to PDF, not printing to PDF if you're going to use PDF. Number 2, create optional communication guidelines or templates that suggest including headings, avoiding repetitive alt text, and providing source files like LaTeX or Word where possible. U of T does this for our archival finding aids, and it's really helped create accessible PDF finding aids. And we're looking to make it mandatory. And there are success stories here. The Indiana University's Institutional Repository team added an accessibility check page in their submission process and saw a 38% jump in accessible uploads, which is a huge deal. Like, that doesn't sound like a big enough number, but that is a big deal. We can think about simple solutions like this and make the world a teensy bit more accessible. Okay, on to the fun AI strategies. I've talked about how terrible PDF is and given some ideas for how to fix them, but what if we got rid of them altogether? We can just let authors provide source files like Word docs or LaTeX markup and convert old PDFs into something better, right? I hope so. Let's test it out, starting with HTML. HTML is basically an inherently more accessible format than PDF because creating structure is required in HTML, whereas tags are optional in PDF. And also, by the way, Archive, the preprint archive, began allowing the publication of HTML copies last year, and there is a growing movement of researchers asking for it to become the standard for accessibility reasons. Anyway, I luckily didn't need to test any converters myself because this incredible study by Patharana et al. Exists. They examined the performance of basically 24 converters. And they, to summarize their great paper in one sentence, came to the conclusion, quote, "No single tool presently available is ideal for text and image extraction." And the HTML they produce is apparently really gross to look at. So that's no good. So HTML is a no-go for converting old PDF documents. I encourage you to look at providing new documents in HTML. But what about LaTeX? Maybe we can solve that math problem. There is a well-known tool for PDF to LaTeX conversions called MathPix, and it has API access, and it's been used in other accessibility workflows already. It seems to work fairly well, but I couldn't find anyone who'd actually tested it with screen reader users, which is baffling, including MathPix themselves, who would benefit from having that information available. So this method requires user testing for sure. Someone please do that. I'd love if you did that. But it's still great to keep in mind. It's a great resource to point students to, and if we talk smaller scale, like converting our high-use math articles and theses, we can think about providing a more accessible LaTeX copy that can sit alongside the official version. MathPix has a free version with a file limit, and there's a paid version that lets you convert unlimited files and gives you API access to the tool, which is pretty neat. It seems like that it has the most potential in combination with another method to convert LaTeX to natural language, which is, of course, ChatGPT. Also, by the way, I wrote the title of this talk before I had read this paper. That's my bad, because I think this is actually really cool. Now, LaTeX can actually be used to make great accessible HTML documents using an add-on called HT-LaTeX, along with great embedded HTML math run by MathJax. But HT-LaTeX isn't compatible with every version of LaTeX, so there's still pretty major issues there. And then you have to know how to read MathML and MathJax. But there's a great paper using artificial intelligence tools, GPT-4 specifically, to make LaTeX content accessible to blind readers by Kortemeyer in 2023. They found that GPT-4 convert LaTeX markup into HTML code if given well-formed prompts. And it provides plain text readings of either LaTeX formulas for readers at multiple levels of expertise, like this conversion here, that's at, unbelievably to me, an undergraduate level, which reads the surface integral over the vector E dotted with the infinitesimal area vector ds equals 1 over the permittivity of free space times the volume integral over the volume charge density times the infinitesimal volume dv. And I actually have a math degree. And reading that after 5 years out of school was impossible, but actually reading that plain text version, I can understand, which is incredible that GPT-4 can actually do that. Notably missing here is the ability to create HTML with MathML that could be read by MathJax, and at the same time providing the plain text version for screen readers. It just can't seem to figure out how to do that. But this is still kind of incredible to me, that it is doing creative interpretation of written math, and I hope it is to you. Well, not written math, LaTeX math. Along with MathPix, this could be a workflow from PDF to an interpreted HTML file. I would also love for someone else to do that work. It unfortunately still has too many shortcomings to make an official cataloged HTML copy with this method, assuming you could even get authors to give you their official LaTeX code. But it's another tool to think about that I think means that there are some great breakthroughs in accessible math that are right around the corner, and I hope we're all excited to watch those come. But these kind of tools are exactly why we should be providing spaces for and encouraging authors to provide their source files. So much potential for creative solutions are lost while PDF is the standard. Let's turn this ship around and let authors submit Word docs, LaTeX files, or even HTML if they want to. Okay, so moving away from pie-in-the-sky imaginings, let's summarize what you can do now to make your documents more accessible. Here are my suggestions. There are so many more. I'm just going to read them out loud. They're succinct calls to action for people in this room. Ensure new documents are more accessible and push authors to never print to PDF. Never, ever, 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 please. If the only thing that happens from this talk is that we get the word out that you shouldn't print to PDF, I will die happy. Number 2, get authors to use headings. And number 3, provide source LaTeX files. It can be a game changer for blind and low vision readers. Okay, number 2, add spaces for alternative formats to PDF, like EPUB, HTML, and source LaTeX files. And number 3, consider performing remediation by hand on your most important documents, and how you define important is up to you. Okay, that is my talk. Time for questions? Or?
No, sorry for, that was a super talk. If there are any questions, we could take some. I think, yes, in the back, Vera.
Awesome talk. I have this question every year at this conference, which is obviously we should encourage people to make their papers more accessible. But I'm also curious, like for searchability, you know, alt text and all this stuff is important to have like on a large scale. But in terms of one person being able to read something, how much of the conversation can be or is, let's hire somebody to like assist somebody who might have low vision reading a paper?
Mm-hmm.
Yeah, thank you so much for asking that question. That was a part of my research that I didn't get to talk about because I only had 20 minutes. Almost all of our services at U of T have a kind of ask for remediation button or something like that. But number one, that's providing kind of a second-class service, obviously, because they have to wait. And that's inherently, if not inaccessible, it's inequitable. And the second part around that is that there is user studies with blind and low vision library users that shows that they tend to just completely avoid any documents that they would have to ask for remediation for because they're busy like the rest of us. And there probably is some comparable source or article out there for them, but it might not be the perfect article. So they just look elsewhere for where they can find accessible copies. So yeah, that's my answer on that.
Thanks. Okay, well, yeah, now it's time for our annual Kate Diebel talk. Kate Diebel talk on accessibility. The title this year is Change is Afoot. What WCAG 2.2 and WCAG 3, am I pronouncing WCAG? Or Wookie 9000, what do they mean for libraries? Kate.
So definitely need to adjust this for my height. While the slides are coming up, Christina, that talk was amazing. For those who attend this, and I'm one of the accessibility people. That was a great talk. I want to chat with you over lunch. So I'm glad we're running ahead because this is going to be tight. So changes afoot. Yep, that's afoot. WCAG 2, 3, 9000, what do they mean for library? So first of all, I just want to warn everyone, this is a lot of talk about technical W3C, the World Wide Web consortium procedures, technical aspects of HTML, CSS, JavaScript, and accessibility laws. So in order to benefit your mental health, I have lots of photos of very cute kitties interspersed throughout this talk. Warning though, they are very cute. They are, yeah, most of them are of my cat, so just a warning there. So WCAG 2.2 is finally here. How many of you have been so excited that this was finally coming? Okay, a few. It's taken 4 years for this to become live. It started in 2020, had many initial working drafts, and this is the public side. This is not the private side. For the record, I was not involved with this except for some of the reviews of all these. Then there was finally an official candidate, and back in July, it became ready for community voting, and it became an official recommendation on October 5th, 2023. I stayed up, late the night, day before and celebrated at midnight like, everyone else did. And then went back to bed because I, was tired and all. But let's dive into the WCAG 2.2 recommendation and what it means for libraries, since this is still relatively new. Very new when, we came up with abstracts for the conference. So the first thing you might be thinking is, why should I care about a recommendation? I mean, it's a recommendation. It's only recommended, right? Well, here's the thing. Remember, the World Wide Web Consortium is not a governing authority, but they are also very, very pedantic. And they like to choose to avoid terminology like specifications or standards because there's a lot of implications from it. They are really big on vocabulary. Every W3C document has a huge glossary in it. And here's the thing though, their actual definition of recommendation even uses the word specification in the first sentence, or the first 5 words. So and then they say standards, and so yeah, I mean it mixes and all that. So despite this definition, almost everyone will say recommendation, specification, standard interchangeably in the accessibility community. So, and if you really want to, if you look at my slides, there's the process document. And by the way, I don't think I hit enter on a message. Can someone take a photo of me? You'll make my bosses happy, and just DM it to me on Slack. So, ideally when there's a cat on this screen. So really, here's the better question. What are my obligations regarding WCAG 2.2? So, first of all, legally, let's talk about this. So I am not a lawyer. You know, the thing librarians are always saying when someone asks a legal question. So in the United States right now, on the federal level, there's one law that has an explicit web accessibility requirement in it, and that's Section 508 of the Rehabilitation Act. And it requires WCAG 2.1 AA compliance, not WCAG 2. Don't get me started on laws that don't adjust for the fact that standards change over time. It will probably be in 2050 that they will finally change it to WCAG 2.2 or whatever it is at the time. There are two upcoming changes to both Section 504 of the Rehabilitation Act and the American with Disabilities Act that are going to be also adding web content accessibility guidelines. I'm giving a lightning talk on those tomorrow to just talk about some of the concerns for libraries that these have implications on. And if you're in Ontario, their law really just kind of specifies WCAG 2.0 AA. And if you're in the European Union, they have a directive that kind of embodies WCAG 2.1 AA, but it's even more complicated and it's European. And so, I'm going to be American-centric like, the world expects us to. So let's talk about this, though. Ethical or moral obligations. I'm tired of doing the, carrot versus the stick, so I'm just going to go with either face the wrath of an angry Fiona or tell Whisper here why you will not help kitties who use Braille readers. Yes, his little paw is on a Braille reader there. And thank you to my friend Sen for letting me use this photo. But remember, WCAG only sets a baseline of accessibility. And you can always do more. You can do more than WCAG, and that's a good thing. And just as much as AA is better than A and AAA is better than AA, supporting WCAG 2 is just as worthwhile. So I highly encourage anyone who does web development to consider this. So what is actually new in it? It introduces 10 changes to the success criteria for the web content accessibility guidelines. And because I'm going to try to actually go over all 10, and I have a little under 10 minutes for this, so strap on your David Lynchian Mentat eyebrows, super bushy, and, be ready to get a bunch of info right away. So first of all, guess what? They removed their criterion. It's no longer do you need to support the criterion 4.1.1 parsing, level A, which basically described as, pages need to be written in proper HTML. You need to use end tags. You should use proper nesting. Make sure your IDs are unique. SpringShare, you need to stop putting IDs on everything that doesn't need an ID, because you fail this one a lot. In fact, actually, SpringShare LibGuides is the only time I have ever cited this previously as a problem. But it's a minor one, and the reason why it's obsolete now is that when WCAG 2.0 was first created back in, mid-2000s, I forget when, HTML was not as standardized, but now the living standard for HTML has actual guidelines for how browsers need to respond to badly formatted pages. So this is covered now. It's now all about basic functionality and not accessibility itself. So you can do this. Now you might be wondering, what if I'm required to maintain 2.1, do I still have to maintain this? No. WCAG 2.1 and 2.0 were edited to include notes on skipping it for the reasons of that, the HTML standard has improved. So here's now one of the new criterions are about keyboard focus. So this is like those little dotted lines you see, or boxes around things when you use the keyboard. And basically, on keyboard focus of an item now, the item and focus indicator have the following requirements. So there are two criterions related to this. 2.4.11 is the minimum one, which is a AA, requires partial visibility. So you should be able to see some of the item and definitely some of the focus indicator. Remember, a focus indicator does not need to be an outline. It can be like a color change or some other things, although color alone is generally not recommended. So you need partial visibility. The AAA version, 2.4.12, requires full visibility of both, within reason. If it's, the entire component fills up more than the screen, you fill as much as you can, but you shouldn't have a component that big. And this often, particularly where it arises, is with sticky headers and footers, which are hugely annoying, or non-modal dialogues, all sorts of reasons. And there is actually some offered guidance on these. So all of the links I have here on these take you to a developer-friendly version of understanding them. The one thing I do like about WCAG is they don't rely on you having to depend upon the reading the actual specification, which I have done, and I don't recommend it. These are actually well-written understanding documents, and there's actually a great example on how to use a combination of CSS primarily and a little bit of JavaScript for just checking sizing to address the issue with a fixed footer, which will also work for a sticky header. There's also now a, you can always tell whenever it's a Mac versus a PC, different versions of Office. There's also a new requirement, a AAA one for the focus appearance has a new requirement. It's AAA, and basically it says keyboard focus indicators should be at least 2 pixels thick, and that if there is a color change, it needs, between the focused and unfocused state, it needs to be a minimum of 3:1. That's very, very low, threshold for meeting that. It's worth noting that this was originally supposed to be a AA requirement, but this was actually the most heavily debated aspect of it all, where people were hesitant about doing this mainly because they were worried people not being able to achieve it. So it got moved to AAA to get things through, which, frankly, this is valuable and easy to do. There's also now a criterion 2.5.7 about dragging movements. So if you do drag and drop or anything, it's really the first WCAG criterion specifically about dragging. And basically, you just need to provide alternatives unless absolutely necessary. And it describes all that. I'm being brief on this one because I never implement dragging interfaces, so don't have much to comment on it, but the link is useful. Okay. There is also now a target size minimum, which basically says that anything that's interactive has to meet a minimum size or at least have sufficient spacing around it. There are some exceptions, usually involved, like if you're legally required to have a very small button, which I don't know why you would have one of those, but hey, it's the law. And basically, it depends on a lot of factors. This one's pretty complex, and you have to read it over there. You could probably do a 20-minute talk just on the requirement. Minimum size is usually around 24 by 24 pixels, which isn't that big. And also, spacing between elements is also required in some cases. And there's actually been a lot of people that developed helpful bookmarklets, so the little JavaScript things to help you support testing. This is Adrian Roselli's. Adrian's a major contributor in the accessibility world. Another new one is support criterion 3.2.6, consistent help, level A. Basically, it says that if you offer support information, things like that, related contact information, it should be consistent throughout the site. Basically, place it in the same location order and help change based on context. You might have more instructions for particular parts of a site. And really, this just helps a lot because if you're already experiencing troubles, you don't want to have more trouble finding help. So it's a great thing to help in regards to spoon theory and all that. And it's good UX in general. And honestly, since we use a lot of different platforms, I think we should really try to keep things consistent across multiple sites. Cat hit mental health break. Hopefully you're not feeling as lost as a cat who suddenly became a killer whale and has no idea where the ocean is. So a few left. New requirement, redundant entry. It's a level A, 3.3.7. When users are filling out a form, they should not be prompted to enter the same information repeatedly. So, oh, you asked for my mailing address earlier in this form. Why are you asking it for again? You know, we all hate these badly designed forms. And there are definitely exceptions, like, you know, you do, you know, confirm the password that you just wrote down in your password change, that's there, or essential reasons such as verifying an email for contact. But basically, just don't ask for the same thing in multi-step process and autofill when you have it available. Make it easier for users. And this is the final one. There's a lot of new conversations about accessible authentication. Basically, any cognitive function test, which is memorizing passwords, solving a puzzle, or CAPTCHAs for authentication. There are two criterion. 3.3.8 is the minimum. It's AA. Oh, I'm running longer than I want. And there's also a AAA, which basically says, you know, more restrictive. And of course, it's going to be easier there. This has a lot to talk about. By the way, pasting passwords from a password manager is an acceptable version for this. That is huge. They just don't want people to block pasting in a password input. But maybe we'll finally have defs of CAPTCHAs. If I had to pick my top 5, we would do these 5 here, the 2 related to focus not obscured. I would definitely try to do the enhanced one whenever you're possible. Focus appearance, also a AAA. But then target size and consistent help. I think those are the ones you should prioritize. That's my advice. Now, what about WCAG 3? Has anyone heard that WCAG 3 is coming or available? Well, guess what? It's not. If you look at the current working draft, which is getting close to a year old, sorry, they've not made an update, and it has so many like sections that say to be filled in. So it's many years down the road, even though some are saying like, oh, we'll get it done in a year or 2. It took 4 years just for 10 criterion. And this is going to be a major change. A lot of different disability types, different conformance approach, which I can go into if somebody asks questions, and even a new color contrast. And I just want to mention, this new color contrast is a proposal. It is not yet approved or going to be part of it, despite the people involved with it. I'm not going to go more into them. But basically, none of WCAG 3 is officially decided on. So you do not need to be following it. Do not appeal to it as better. It is not official yet. Don't use it. And I do not expect it to be present for a long time. They've said that they won't do a 2.3, but I'm out of time. Or, no. Yeah. But WCAG 9000, that's a meme, so, you know, it's just not possible. But hopefully you don't look like Fiona here with her eyes crossed and tongue sticking out. But that's everything there. I will answer questions in there. I only went a little over. Whew.
So Kate, we don't have to worry about WCAG 9000? That was a joke? No 9000? So you know how doctors have to do CME things and like, you know, they go to conferences and get check boxes to like they have had continuing medical education? Well, I think we should thank Kate for providing us with continuing accessibility education. Thank you, Kate. So unless anyone has some burning questions for Kate, we'll go on to the next talk, which is Robin Davis and Meredith Wynn. And they're going to talk about Beyond Band-Aids, Rethinking Accessibility Widgets.
everyone. Welcome to Beyond Band-Aids, Rethinking Accessibility Widgets. I'm Meredith Nguyen.
And I'm Robin Davis.
And we're very aware that we're the thing standing between you and lunch, so we're going to dive right in. So we've been really fortunate to have a UX team here at the NCSU libraries who's very committed to web accessibility. It's taken a really long time, but we're really proud to have a fully WCAG 2.1 AA compliant site. That journey is not what we're here to talk about today. We're here to talk about some of the gripes that journey gave us with these third-party accessibility widgets. So first, Robin's going to take us through a live demo.
Or attempt to. Everybody wish me luck. All right. So here is our library website. You may notice in the lower right-hand corner, there's a little red tab that says Readability. If you pop it open, it gives you some options to perhaps enhance the readability of the page you're looking at. You can turn on the warm background option. You can highlight links. You can turn on the open dyslexic font. You can hide images, although not icons. And you can do all of them at once. Woo. All right, so that's what we will be talking about today. How we made it and why we made it.
So what are those third-party widgets that I was talking about before? Well, when browsing the web, you might notice these little floating icons somewhere on the page. So they might be on the side, they might be in the header or the footer. And normally when you click that icon, a widget pops up with a bunch of options to improve the accessibility of your site. The problem is that a lot of these options should not be enhancements to the core functionality of your website. So keyboard navigation, video captions, not auto-playing animation, these are core accessibility features. They are not optional enhancements. The marketing text for this third-party widget actually promises to solve web accessibility just by adding one of those widgets onto a non-accessible site. And to us, that is like trying to put a Band-Aid on a broken foundation. There's just nothing that can replace a fundamental commitment to web accessibility and really working that into your everyday practices into web development. So those were our initial concerns. They don't address the underlying accessibility issues. WCAG compliance is not an optional enhancement. And we also worried that users might have some of these accessibility tools on their own devices, rendering these kind of redundant.
So we had the good fortune to meet a student disability advocate and researcher named Jordan Berkner, who accepted our invitation for a paid interview about accessibility, one of her research areas. One takeaway from that conversation was that accessibility needs may be in conflict between users. For example, black text on a white background is great for users with low vision who may prefer high contrast, but black text on a cream background, like on this slide, is great for users with dyslexia or great for users who may be reading at night in a dark room, when lower contrast may be preferred. So for this and for some other aspects, there's no necessarily one-size-fits-all solution. Our website should be universally designed so that most people can use the vanilla or plain version or use it with their own accessibility tools, but some features could be useful for a small population. Her second point was that not all users can customize their device with accessibility plugins, as we'd originally assumed. For example, some users might be on a locked down work device where they can't install stuff, or similarly maybe using a library computer where they can't install stuff, or maybe they just haven't done a deep dive into accessibility plugins and software, even though that may be useful. It may help them be able to make big pages more readable. So a widget could be useful in these situations as well. Furthermore, the mere presence of these tools is a signal to disabled users and neurodiverse users that we care about their needs and that their needs are valid and deserve attention. The person that we interviewed is autistic, and when she looked at another project that we worked on and saw the sentence, "We designed these maps for users with sensory sensitivities, like some autistic users," she said that this is what she thought. Oh, they thought of me. They're not scared of the word autistic. So talking to Jordan convinced us that a readability widget could actually be useful for our library's website and meaningful to our users as well.
So now that we know that these extra widgets actually could have real benefits for our disabled and neurodivergent users, how do we figure out which features would be useful and how to incorporate them in our site? We ended up focusing on two universal design principles of perceptibility and user control. Perceptibility is exactly what it sounds like. Perceivability is what WCAG refers to it as. And this is all about how easy it is for users to take in information from your website regardless of their sensory abilities. So for example, including alt text on images means that people who cannot visually see the image can still perceive that same information. Similarly, user control or flexibility, as it's referred to in the Universal Design Guidelines, is very self-explanatory. It's just about offering users direct control over what they see on screen. So undo or reset buttons, customizable layouts, navigational tools, all of those offer users more control. So combining those two principles, we want our widget to give users more control over the perceptibility of our site, especially when accessibility needs may conflict. How do we do this? Well, we first started off with research because we are librarians. We did a literature review of best practices and research in the field for these sorts of features. And we also checked with our campus disability resource office to determine that ADHD, learning disabilities, and autism spectrum disorder were most prevalent on our campus. So with this and our conversation with Jordan in mind, we identified the features we wanted to include. Robin then led us in a design phase using Whimsical and Figma. And Eric Olson, the other developer on our team, and I then set up weekly pair programming meetings to implement our design. Finally, we did a round of on-the-spot usability testing using our Tiny Cafe model, which Robin will tell you more about in a bit. So we already talked about that goal of the combination of control and perceptibility. We also wanted to avoid the feature bloat that's really common with these. We wanted to keep it really short and sweet. And we also wanted the widget to be very lightweight and performant. We have a really big website already, so we weren't interested in adding more dependencies or something really heavy. So this is some of our wireframes where we experimented with placement and user interaction patterns and labels for each feature. This is Robin's extremely impressive Figma prototype. This allowed us to fine-tune the interaction and widget design before we dove into implementation. And we're just going to take a bit of a closer look at some of the features that Robin pointed out in the live demo. So as we're going through these really quickly, because I know we're short on time, just take a look and see which of these pages are maybe easier for you to read or scan based on your own different abilities. So this is a page about our Hill Library renovation. This is the warm background. These are those highlighted links. This is that open dyslexic font, which research shows can be easier for some dyslexic users to read. Research also shows that some neurodivergent users find it easier to read large amounts of text when there's not images sprinkled in between, so that's what the hide images option is about. And finally, like Robin said before, you can do all four of them actually. So this is what it looks like to do all four at once. Once we had our features list, we moved on to those pair programming sessions to actually implement the design. So to keep it lightweight and performant, we just used vanilla HTML, CSS, and JavaScript, no packages, plugins, anything like that. It's fully open source, which I'll talk about in a second, and that was so that we could offer it to other applications at the libraries on different platforms. Of course, it's keyboard navigable, and we use semantic HTML5 with ARIA so that those screen readers could also take in that information.
I'll speak briefly about some user research that we've done and metrics that we've collected. So before we launched the widget on our website, we held a pop-up usability study, which we call a Tiny Cafe, where participants could try it out and give us feedback. Okay, we know that using a convenience sample, like chatting with passersby, is not the greatest way to get feedback on a widget that we designed with specific users in mind, but we hoped it would be useful anyway, and I think it was. So about half of the 18 participants noticed the widget button on the bottom of the page before moderators directed their attention to it. So it was a sort of good combination of visible and unobtrusive, we thought. For the way that the widget looked, participants rated it an average of 4.5 out of 5, nice. And for usefulness, they rated the widget an average of 3.3 out of 5, although they noted that there were some features that may not be useful to them, but could be useful to real people that they knew in real life. When we launched the widget, we called it an experimental feature, and in fact, we still do. It's an ongoing experiment. So to ascertain how well it's working, we included a feedback form on the widget itself. Amazingly, we've only had positive feedback so far. So here's what some real users had to say. Also, I didn't see what you lifted up. Okay, great. I'm going to keep on going. So on that feedback form, we've only gotten positive feedback, which is awesome. So one user said, "Thank you for the dyslexic-friendly font. It's usually so hard to read web pages because it takes me so long, so I feel really represented." Heart. Oh, that's great. I was delighted to find the readability option, said another user. "The warm background plus open dyslexic font options are especially great. Thanks for the implementation." A few metrics. In the past 10 months since we began tracking it, the widget's been opened around 3,000 times, and surprisingly to me, the most used feature is highlight links.
Like I mentioned before, this is open source, so if you want to add the widget to your site, you can definitely do that. I think the accessibility guideline says I was supposed to read this out loud, so go.ncsu.edu/rw is the Go link. You may not want the widget to be all in Wolfpack red like we had it, so feel free to adapt it as you need. Definitely make sure to test on a bunch of different pages to make sure our specific implementations of these are going to work with your markup. And finally, launch and hopefully make your site more readable for your users. We definitely have to acknowledge Eric Olson, the co-designer and co-developer of the widget, who isn't here. Thanks, Eric. B was a libraries fellow who helped us with our user research. Jordan was the student that we talked with who gave us a different perspective on accessibility widgets. And finally, all the great participants at our user research table. We couldn't have done it without y'all. Thank you.
Thank you, Rob and Meredith. Let's have a hand for all of the speakers who kept to time. And we're almost there. Pre-lunch announcements. If you are an in-person speaker giving a talk this afternoon, please come up to the podium during lunch to load your talk and check out the setup. Also, now is a great time to sign up for a lightning talk or a breakout section for tomorrow on the flip charts in the lobby. This building is going to be remaining open and unsecured during our lunch break. Please bring any of your important belongings along with you. Lunch will be served in concourse, the alcove across the hall. Seating is available in the two rooms off concourse, Hussey and Vandenberg. And tables will be set across the hall in Michigan. So go to lunch. Thank you, everybody.